welcome. Today's lecture is going to cover double replacement reactions and the solubility chart. So you're able to look at your double replacement reaction and see if in fact it forms a precipitate or if it does not. Okay, so just a quick refresher on double replacement reactions. If you guys remember, typically it's between two compounds. Okay, so these are made up elements, obviously compound AB plus compound CD. And what typically happens is your two positively charged ions, which in this case are A and C, flip-flop spots. So then in the products, you would have A and D plus C and B. Okay, we've done this before. This is a double replacement reaction. From there we would balance, and then the new step that we'll be learning today is how to identify if a precipitate forms. So let's look at a few examples. Okay, so with our first one, we have sodium chloride and silver nitrate. Okay, the first thing that you want to do is identify the charge on all of your ions. So we know from our periodic table that sodium is +1, we know that chlorine is -1, and we know that silver from our periodic table is +1, and we know that nitrate is -1. Okay? So once you've established the charge, then you want to show the exchange between the two positively charged ions. Okay, so in this case, silver and sodium flip-flop spots. And in the products, you would write just what you have. So we have now NaNO3 plus AgCl. Okay? Now the nice thing about this is since it's all +1, -1 for your charges, you don't have to add in any subscripts. And since you don't have to add in any subscripts, all of the equation is balanced. So we go from there. Okay, now in identifying if you have something that's forming a precipitate, you need to use on the back of your periodic table the solubility chart, and you can find this in the bottom right hand side. Okay, so looking back at what we had in our products, we had sodium and nitrate. So what I do is I find sodium and I find nitrate and I sort of match them up. And if you see that something is an S, S stands for soluble, which means that it does not form a precipitate. So since it doesn't form a precipitate, its state of matter is AQ, so it's aqueous. Okay, we're looking at Ag and Cl next. Okay, so we have silver and we have chloride. Here you can see that it's an I. Now for our rules, if it's not soluble, if it's not showing an S, that means that it's insoluble, that means that a precipitate forms. So we would write here an S for solid, stating that yes, a precipitate did just form. Okay? Let's look at the next one. Okay, so our steps for this equation again are identifying the charges, so you want to do that first. So hydrogen's +1, chlorine is -1, lead in this case is +2, and nitrate again is -1. Okay, your positively charged ions flip-flop spots. So now what we have in the products is HNO3 plus PbCl. Okay, now look at your charges again. You have +2, -1, +1, -1. You have an imbalance here, so you need to crisscross your charges so the 2 goes to the chlorine. Okay, here it's +1, -1, so it stays, it's fine. Now since you do have an imbalance in the ions, you have to go back and balance the whole equation. So I have 2 chlorines, I have 1 chlorine, so I got to put a 2 here. I have 2 hydrogens. I only have 1 hydrogen, so I got to put a 2 here. Now I have 2 NO3s, I have 2 NO3s, I have 1 lead, I have 1 lead. So it works, it's balanced. Now we got to go and see if any of these form a precipitate. So we check right here. The first one being hydrogen and nitrate. Okay. For this one, we actually don't have hydrogen on our list here, which is unique. So we're going to assume then that this forms aqueous, okay, because it's not on our list. For lead and chlorine, so we find lead, chlorine is chloride, so we match them up. We have the SS, which is slightly soluble, which technically does not count as soluble, so we assume that it forms a precipitate. Okay, so if it forms a precipitate, you want to put a box around that precipitate. Okay, and that's actually something that I forgot to do on the previous one. We're going to put a box around AgCl. Okay, so we have our precipitate that's formed. This is our solubility table. We'll do one more. Okay, we have zinc and sulfate, we have barium, and we have chlorine. Okay, just checking, barium and zinc are both on here. So we'll be able to do this one. So again, first thing you want to do is identify your charges. So zinc is a +2, sulfate is a -2, barium is a +2, chlorine is a -1. You flip-flop your positively charged ions. So now I have BaSO4 plus ZnCl2. Okay, and we can write in the ZnCl2 because when you go back and look at your charges, you have +2, -2, you have +2, -1. So this 2 transfers over to the 2 for the chlorine. The 1 goes to zinc, which it has a 1 right there. Okay, now what you want to do is let's balance first. We'll balance the equation. So I have 2 chlorines, 1 sulfate, 1 barium, 1 zinc, 1 zinc. So you can see that it is balanced. And then we're going to go back and we're going to look at to see whether they're soluble or not. So our first one is BaSO4. So we have barium. We're looking at sulfate. It's an I, so that forms a precipitate. So that means that would be a solid. And we put a box around it. Next one is zinc and chlorine. This is showing an S, which means soluble, which means no precipitate is formed. So it's AQ. Okay? That should cover it. From here you want to work on